We're doing number 1 for Algebra 2. It says the Richter scale is used for measuring the magnitude of an earthquake. The Richter magnitude is given by R equals 0.067 log 0.37 E plus 1.46, where E is the energy in kilowatt hours released by the earthquake. An earthquake releases that much kilowatt hours of energy. What is the earthquake's magnitude? All right, so the magnitude R is what we're looking for. So we're going to plug in that number in for E. So we can say R equals, and it's going to be 0.67 log. Notice how it's log base 10 because there is no number. We have 0.37 and then times E, 15,500, and then we've got 1, 2, 3, 4, 5, 6. Close our parentheses and then add 1.46. Alright, so this is for 1A. So we have all that stuff. What's the earthquake's magnitude? Now all you do is just plug that into your graphing calculator or calculator that you have, as long as it's got logs in it. Okay, I can't really do all this at one time and see the numbers, so I've got to move it over here and then I'll move my calculator back once we're done. So I'm going to type in 0.67 log and 0.37 times 15,500, close my parentheses, plus 1.46. And if I hit enter, 7.9982. Since it doesn't say that, I would say let's round it to 8.00. So we can say it is, the R is going to equal 8.00. Now, if you think about the Richter scale, if you've ever heard that before and someone says, oh, there was an earthquake, it registered something on the Richter scale. Usually, 8 is a pretty good number. 8 is, I shouldn't say a good number, but is in the realm of possibilities. Okay, if you get a number like 100, that's way too strong for the Richter scale, because that's going to be way, way too strong, like the Earth is falling apart if you get a number like that. Okay, so there's part A. The Richter scale is going to be about 8. That's the magnitude. Part B, how many kilowatt hours of energy would an earthquake have to release in order of an 8.5 on the Richter scale? So now what we're going to do is we're going to plug in something to that same equation, but now we're saying 8.5 on the Richter scale. So we're going to say 8.5 equals 0.67 log base 10 of 0.37 E was the letter they used, plus 1.46. Okay, now we want to solve, and we're going to do order of operations backwards. How do you undo add 1.46? Subtract 1.46. Subtract 1.46. And 8.5 minus 1.46 equals 7.04. So 7.04 is going to equal 0.67 log of 0.37 E. Alright, from there, divide by 0.67. Divided by 0.67, and you should get 10.507 about is going to equal log of 0.37 E. Now I'm okay with you writing, if you can see, there we go, I'll put that there. I just wrote some of the numbers, even though I have all the numbers here. I'm not going to write them all now and then have them in my calculator. I'm going to keep it in my calculator, but I'm going to not write them all. That's okay to do. Alright, so don't use this number, use the number that's in your calculator. Okay, if I want to figure out what number this is, I need to rewrite this log as an exponent. Remember how we had done that before? We wrote exponents as logs and then logs as exponents. We're going to do that. So it's log base 10. Remember, you go from the base to the number on the other side of the equal sign equals that. So it's going to be 10 to the 10.507 is going to equal 0.37 E. Right? Base 10 of this number equals the stuff after the log. Base 10 of this number equals the stuff after the log. Okay, now I could just get this to be a number, but I want to do all those calculations last. So to find out E, I'm going to divide by 0.37. Divide by 0.37. I'm guessing it's going to be a fairly large number if we looked at the original was, what, 15 billion? So let's try it. What I'm going to do is take 10 to the x. If you see the log button, it's the second log. So if I hit second log, that's 10 to some power. Instead of typing in 10.05, all that stuff, if I hit second negative, it gives me the answer from the previous line. So that way I don't have to type it all in. So I do that. I'm going to hit enter, get that number, divide by 0.037. And it says 8.69 ... e to the 11. E to the 11 is times 10 to the 11th equals E. So times 10 to the 11th, which means how many times do you have to move that decimal point? 11. So we have 8, 6, 9, 4, 8, 2, 7, 3, 4, 4. If I write it all out, I need to start here and move 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's my decimal point, those two numbers. So, comma, 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 comma. 8, comma, 6, 9, 4, comma, 8, did I say that right? 0, 0, 4, comma, 4, 3, 7, comma, 8, 2. Whew. All right. There's a whole lot of numbers going on. Let's try that one more time. I'll start backwards that way I don't make any mistakes. 0, 0, 4, comma, 4, 3, 7, comma, 2, 8, 4, comma, 9, 6, 8. So that's how many kilowatt hours of energy is in an 8.4 Richter scale. All right, there you go. That's how you do number 1 on this word.